Welcome back. Are we ready to level up our stablecoin? Right now our stablecoin's pretty vanilla, so let's make it look a bit more like the actual crvUSD and add this concept of liquidity ranges. To do so, we're going to introduce the Vyper dynamic array. Since this tutorial began, Curve has released the full details of their crvUSD. And spoiler alert, the actual crvUSD is a bit more complicated than the silly little one we're building for this tutorial. We essentially have a stablecoin and an associated minter which manages all of this. The actual crvUSD breaks this down into multiple different contracts to do things like handle monetary policy, peg, AMM connected with it. So it's much more robust, and we certainly recommend you read through the GitHub repository to see an example of advanced Vyper in action. See what you can understand and ask us questions where you don't, because we could possibly do some tutorial videos. One of the things that we're going to do in this tutorial video is we're going to show you how you could bring our crvUSD simple token to be a bit more like this through this concept of liquidity ranges. One of the things introduced by this AMM is this concept of continuous liquidation and de-liquidation over a range of prices. So you might imagine if Ethereum is, let's say, $1,000, you could, instead of saying liquidate me when Ethereum hits $800, say give me a smoother experience and liquidate me down from $800 down to $200. So if the price wicks down, you don't necessarily lose everything. And this stablecoin, in fact, goes further and de-liquidates you as the price goes back up. So it provides a much more robust user experience. We're not going to be able to get into all of that today, but we are going to show you how you can create this concept of adding liquidity over a range of bands within this tutorial video. And this is a bit more advanced, and as such, the tutorial video here is not going to show the complete solution, but rest assured the solution is in the GitHub, so you can proceed and check your work. We're just going to show you the concepts you need to make it happen. So you notice when you look at this, this is being returned in JavaScript to the front end as sort of like a more complex multi-dimensional object. We really only have one type we've looked at in Vyper so far, which allows for something like this, and this is a mapping. And we don't think a mapping would be appropriate for this. A far better idea would be to use Vyper's dynamic arrays. Vyper dynamic arrays function a lot like a list in Python, and they have functions associated with it like append and pop, which you'll be familiar with if you've done any Python programming involving lists and data. There is a slight difference though, which is that the Vyper dynamic array, which will grow and shrink in size, does have to have a fixed cap. So you could make your cap for the array 1,000,000, 1,billion, but just bear in mind that the EVM itself is not actually infinite. So there's a big difference between Vyper and Solidity. In Solidity, if you're dealing with an array, you don't have to declare a cap, so you can just keep adding elements forever. But the EVM is going to run out at some point because it is finite. Vyper says, since it's finite, we're going to require you to cap it. So in this case, this is a dynamic array that could have 0, 1, 2, up to 3 elements. But if you try and do anything beyond that, it's going to revert. Because of this, though, Vyper is able to store it a lot more efficiently. So this is sort of the perfect structure that we need, which means that you can add a array with one single liquidation band, which is essentially how the coin currently functions, or you can have it be smoother and added over a range of liquidity bands. So we're going to go ahead and give you everything that you need to create this. So the way that this is going to work is we're going to update our structure to, instead of looking at a liquidation price, we now are looking at a liquidation range, which is now going to be set to this dynamic array. And similarly, instead of adding all the collateral at a specific price, we're going to add collateral at a range of deposit amounts. So this is going to require 2 different dynamic arrays. We instantiate the dynamic array by saying what variable type is going to be in it, followed by the max value. And let's say we want a max value of 10. We could write 10 every single time, but that would be what's called a magic number. And we want to make this in a way that's easier for the reader to understand. So we're actually going to set this magic number as a constant within the smart contract. So anyone reading through is going to be able to see a more like plain text description of what this is. To do so, we're going to create a constant. A constant within Vyper is defined directly when you instantiate the variable, and it's set, it's fixed, it could never be changed. So for this example here, the total supply is being set to 1,000,000. And then every time you see the word total supply, Vyper just subs in 1,000,000. It's a literal value, and that allows us to use some of the operations within Vyper which actually require you to pass a fixed value. It can't be dynamic. For example, when you're looping through a range, Vyper doesn't let that range be dynamic. It has to be a fixed number. But by setting a constant, it's the next best thing. Notice the convention is to set constants in all caps. It's a convention. You don't have to do it. But we're going to create max bands as a constant. It's a uint256, and this will be set equal to 10. You could change this to 20. You could change this to 30. However many liquidity bands you want to cap the user at. We'll do the same for deposit amounts. And now our task is to go through every single place where we were referencing either the liquidation range or the deposit amounts and fix it up. We're not going to do it all in this video, but we're going to get started and allow you to do the rest. So our internal functions is a good opportunity to show how we can practically work with the dynamic array in practice. Specifically, we have this repay amount function. Used to be so easy. We just grabbed the liquidation price and multiply by the deposit amount. What we need to do instead is we need to loop over all the liquidation ranges and then also run the deposit amount equation that we see here at each band. So let's go ahead and create a loop. And we could type 10. We can also type max bands, the constant we created. What you can't do with the range is you can't have it be dynamic. You can't say, get the current length of the dynamic array. This would be helpful, but the way that you can deal with this is, say that you only have one liquidity band, but you're doing a loop of 10 here. You don't want to spend gas to go through each step of the loop. So we're going to add a break function. That is, if the current band we're at is now greater than the length of the liquidation range array, then we're going to break this loop. So the very first time, if you have, we're doing this loop 10 times. If you have to have one liquidation band, so you're going to get past this the first time because I is going to be 0, the length will be 1. But then the next time you hit it, I will be equal to 1. This will be equal. It's going to break and it's not going to run this. Other than that, we're going to now step through and have a return variable that gets updated each step of the way. So the total repayment amount is going to be a uint256, which we're setting equal to 0. And at each step throughout this, we're going to take this and we're going to add this formula, which used to be so easy, but now needs to be updated because it's no longer liquidation price. It's a range at this index, and it's deposit amounts at this index. And then, as before, we return the repay amount, and we divide by 10 to the 18th as we did before. So this is the basic concept you're going to need to do, but you need to take a look at all the state modifying functions. All the state modifying functions at the end are using the old way. You're going to need to update the logic. So this is a bit more advanced. This can liquidate function is also going to need essentially the exact same treatment because it's no longer quite so easy to see if you can liquidate. You have to look through every single step of the liquidations and see if it can be liquidated. Similarly, we're going to want to add a deposit amounts function because we used to just be able to read the deposit amount. But now that the deposit amount is spread out over several different bands, you're going to want to run this exact same logic. So again, check the solutions file, ask questions in the comments, share your solution with us. We'll be happy to audit it and let you know what we think of it. If you have any issues with this, maybe we'll record a companion video walking through the solution file in more detail. But for the time being, this is a really good advanced exercise. And if there's any other features you'd like to add to the stablecoin, let us know. And we can possibly add some supplemental videos to this tutorial covering some more of the advanced concepts within the crvUSD and how you could implement it with your stablecoin. Good luck.